I'm Adam from RFOXiA, from our real lab. Today we are answering the question, what does 8,800 joules actually mean for a piece of hardware sitting in a field running all day with no outlet in sight? Enjoy our new soundtrack at the end of the video. Let me start with the joule because most engineers have a complicated relationship with this unit. You learned it in a physics class, it was on the exam, you got the answer right, and then you spent the next decade thinking in milliampere hours because that is what battery data sheets use, and you quietly agreed to never think about joules again. That was a mistake, not a catastrophic one, but a mistake that makes power budgets harder than they need to be. A joule is simple, 1 watt sustained for 1 second. That is the entire definition. If your device draws 1 watt and you run it for 1 second, you have consumed 1 joule. If you run it for 10 seconds, 10 joules. If you run it for an hour, which is 3,600 seconds, you have consumed 3,600 joules, and you have also consumed 1 watt-hour, which is the unit you are probably more familiar with. Those two units describe the same physical quantity. Joules and watt-hours are not different things. They are the same thing measured on different scales. 1 watt-hour equals 3,600 joules. That is just multiplication. There is no hidden complexity. The reason this matters is that 8,800 joules is a real number describing a real physical system, and if you understand joules, you can immediately verify whether that number is plausible without trusting anyone's marketing copy, including mine. So let us do that verification. The Multinav Pro Plus BLE module draws approximately 8 milliamps during active operation at 3.3 volts. That is the radio running, the processor active, data being transmitted. Power equals voltage times current. 3.3 volts times 0.008 amps equals 0.0264 watts. Call it 26.4 milliwatts. Now let us define a working day. 8 hours is standard. 8 hours is 28,800 seconds. Total energy consumed 0.0264 watts multiplied by 28,800 seconds equals 760 joules. So to run a BLE module continuously for 8 hours, you need approximately 760 joules. The power program kit stores 8,800 joules. That means the module, running flat out for an entire 8-hour session, consumes roughly 9% of the available energy. You have a factor of 11 margin. You could run 11 BLE modules simultaneously for a full day on this kit, or you could run the full Multinav Pro Plus ecosystem, the BLE module, the GNSS module, the sensors module, all simultaneously, and still have substantial capacity remaining. This is the correct way to think about energy storage. Not in terms of how much capacity you have, but in terms of how much margin you have against the actual load profile of the system you are building. Now let me address why this is a supercapacitor and not a lithium battery, because that question always comes up and the answer is more nuanced than most people expect. A lithium battery stores energy electrochemically. The charge and discharge process involves chemical reactions. Those reactions are not instantaneous. They have preferred rates. Push too much current in too quickly, fast charging, and you generate heat, degrade the electrolyte, and reduce the total number of charge cycles the battery can sustain before its capacity drops below a useful threshold. Most lithium cells are rated for somewhere between 500 and 1,000 full charge cycles before meaningful degradation. After that, the capacity is reduced and the chemistry has aged. A supercapacitor stores energy electrostatically. There is no chemical reaction. The charge is stored in the electric field between the capacitor's electrodes. Because there is no chemistry being stressed, you can charge it as fast as the electrical limits of the system allow. You can discharge it rapidly without degradation. And the cycle life is not measured in hundreds or thousands, it is measured in hundreds of thousands. The physics of electrostatic storage simply does not accumulate damage the way electrochemical storage does. The consequence of this is the 5-minute charge time. That is not a marketing claim, it is a direct consequence of the physics. You are pushing 10 amps into a system that accepts it without complaint because there is no chemistry to protect. For field deployment, for drone operators, for remote sensor networks, for researchers collecting data in locations where power is inconvenient, this changes the maintenance profile of the system entirely. You are not managing battery replacement cycles. You are not worrying about storage voltage when the equipment sits unused for 3 months. You plug it in for 5 minutes before you need it, you unplug it, you go. The 1100 farad capacitor in this kit, charged to 4 volts, stores energy equal to 1/2 times capacitance times voltage squared. Half times 1100 times 16 equals 8800 joules. That is the derivation. It is high school physics applied direct. So that is the math behind the number. 8800 joules, where it comes from and what it covers in practice. Now let me show you the actual hardware. This is the 1100 farad supercapacitor system, the component that makes the 8800 joule figure real rather than theoretical. 1100 farads at 4 volts gives you exactly that number by the half CV squared formula. It is a large capacitance value for a reason. The working day calculation required it. The physical system was designed to match the energy budget, not the other way around. This is the charging adapter. 12 volts, 5 amps input, delivering 10 amps directly into the supercapacitor stack at 4 volts. The 5-minute charge time is a direct consequence of that current. A lithium battery management system would reject this charge rate as damaging. The supercapacitor accepts it without concern because there is no chemistry being stressed. This is the adapter that makes the field deployment case work. This is the full Multinav Pro Plus stack drawing from a single power program kit simultaneously, BLE module, GNSS module, sensors module all active at once. The combined load across all 3 modules still represents a fraction of the 8800 joules available. The kit was not designed to power one module for one day. It was designed to power the complete ecosystem and still have margin remaining. This is the S-Link programmer integrated directly into the kit. Firmware development for embedded hardware has always required a separate programmer, a separate cable, and usually a moment of confusion about which connector goes where. The programmer is here because field deployed hardware occasionally needs a firmware update, and the update tool should be in the same case as the power system, not left on a bench somewhere. This is the complete connectivity kit, flat ribbon cables connecting the BLE module to the power board and the programmer to the BLE module. These cables are not an afterthought. The geometry of flat ribbon cables in confined enclosures is a practical constraint for anyone who has spent time assembling hardware in the field. Everything required to connect the full system is included, and the routing is predictable. Product specification. The number is not arbitrary. It follows from the choice of capacitance and operating voltage, and both of those were chosen deliberately to produce a system that covers the full Multinav Pro Plus stack for a working day with margin. The mission statement for this product is precise. The kit stores enough energy to power your BLE module through a full working day, so you can measure your sessions in completed experiments rather than battery warnings. That sentence was written by an engineer, not a copywriter. It means exactly what it says.
5 minutes on the dock, full charge and I'm unlocked. Capacitors hold the line while batteries fall behind. Field ready every time, no waiting, no decline. Plug it in, fire it up, one connection, that's enough. Never stop, never train. 5 minutes and I'm back again. Charge the full, run all day. Connect the at the SWD pins. The programming begins. Flash the firm on clean. The sharpest stack you've seen. BL breathing live. All sensors locked and primed. From bench to open sky, nothing slows this drive. Supercapacitor surge, instant energy in reserve. No cell degradation, every charge is full and pure. ST-Link ready, write the code and push to hardware. Field deployment, no excuses, always there. Never stop, never train. 5 minutes and I'm back again. Charge the full, run all day. SWD lights the way. Never stop, never train. 5 minutes and I'm back again. Charge the full, run all day. SWD lights the way. This circuit was designed to shine. SWD, full power.